Hi, today my team and I will be presenting on the Unified Modeling Language, or the UML. My teammates and I consist of me, James Idforminich, Landon Woolley, and Daniel Martin. Next slide, please. So the overview. So today we'll be explaining what a UML is, and we'll be talking about the different types of UML, as well as focusing on the class diagram and its uses and effectiveness, as well as its advantages and disadvantages. And we'll be giving an example of a class diagram, and then we'll be talking a little bit about the application to our project, which is the Eagle Scout project. Next slide, please. So just to explain what a UML is, UML stands for Unified Modeling Language. It is motivated. Its creations motivated by the desire to standardize the disparate notational systems and approaches to software design. It was adopted as a standard by the Object Management Group in 1997, and this organization has been managing the UML ever since. And in 2005, UML was also published by the International Organization for Standardization, or the ISO, as an approved ISO standard. It's a graphic-based modeling system, and basically what it is it's a general-purpose developmental modeling language in the software field that's intended to provide a standard way to visualize the design of a system. And it does that by including elements such as any activities or individual components of the system and its interaction between the various components, and how the system will run and the entities and such. Next slide, please. So there are two types of UML that we'll be talking about, which are the structural and the behavioral types or diagrams. So structural diagrams emphasize the things that must be present in the system being modeled. Since structural diagrams represent the structure, they're used extensively in documenting the software architects of the software systems. And some of the structural diagrams are the class diagram, which we'll be focusing on today, as well as the object diagram, the deployment, package, component profile, and composite structure diagram. And for example, we'll be using the component diagram. The component diagram itself describes how a system is split into various components and showing the dependencies between those components. So it's basically the parts and the structure that is in the system that's focusing on. Next type is the behavioral diagrams, which are emphasize what must happen in the system being modeled. Since behavioral diagrams illustrate the behavior of a system, they're used extensively to describe the functionality of the systems instead of just the components or the parts. And some behavioral diagrams are activity diagram, the interaction diagram, the state machine diagram, and the use case diagram. So we'll take the activity diagram as an example, which describes the business and operational step-by-step activities of the components in the system. So it focuses more on how the parts work in the system, more so than just what the parts are. Next slide, please.